Welcome to the AWS Certified Cloud Practitioner Prepcast, where we guide you through everything you need to know for your certification exam. Whether you're just starting or looking to refine your knowledge, this course will set you up for success. Brought to you by baremetalcyber.com. Let's get started. As we close out Domain 3, it is helpful to step back and look at the big picture of AWS cloud technology and services. This domain has carried us through compute, networking, storage, databases, and more, showing how each service fits into the AWS ecosystem. At first, it can feel like drinking from a fire hose, but the real key is pattern recognition. Which service solves which kind of problem, and why? If you can map requirements to the right categories, compute for processing, storage for durability, networking for reach, databases for structure, then the complexity becomes manageable. By reviewing these core maps, you reinforce not just memorization but the logic behind AWS service selection, which is what exam questions really test. Let's begin with compute. Here the main decision rests on how much control versus abstraction you want. EC2 represents the traditional virtual server model, giving you the most control over operating systems, networking, and patching. ECS and EKS bring containers into play, abstracting away some management while still letting you control deployments. Lambda and Fargate push abstraction further, removing server management entirely. Lambda executes code in response to events, while Fargate runs containers without provisioning instances. Understanding these trade-offs is essential. Do you need fine-grained control, container orchestration, or pure event-driven compute? The exam often signals the answer in the scenario language. Long-running workloads hint EC2, microservices point to ECS, EKS, and event-driven automation favors Lambda or Fargate. High availability is another recurring theme. The three pillars here are multi-AZ deployments, elastic load balancing, and auto-scaling. Multi-AZ ensures resilience by distributing workloads across physically separate data centers. Load balancers distribute incoming traffic across multiple instances or containers, improving both availability and performance. Auto-scaling adjusts capacity dynamically, so you maintain performance without overspending. Together, these features form the backbone of AWS reliability. Think of them as the safety net. Your infrastructure may falter, but these tools catch the fall. For the exam, remember that multi-AZ plus auto-scaling behind a load balancer is AWS's standard high availability pattern for web and application tiers. Networking anchors are easy to get lost in, but the fundamentals are clear. Every architecture begins with a virtual private cloud or VPC, which is essentially your own private slice of the AWS network. Subnets divide that VPC into segments, often by availability zone or function. Security groups act as virtual firewalls at the instance level, controlling inbound and outbound traffic. Network ACLs or NACLs provide subnet-level filtering for an extra layer of control. Endpoints allow private access to AWS services without traversing the public internet, a key tool for secure architectures. If you keep these roles straight, VPC as the container, subnets as divisions, SGs for instance security, and NACLs for subnet rules, you can orient yourself quickly in almost any networking scenario. Connectivity choices are about bridging AWS with users or other environments. The Internet Gateway is the simplest path, connecting public subnets to the wider web. VPN connections extend private networks into AWS securely over the Internet. Direct Connect provides dedicated private links with more predictable performance. Transit Gateway, or TGW, helps stitch together multiple VPCs and on-premises networks at scale. On the exam, look for keywords. Low-latency private connection suggests Direct Connect. Hub-and-spoke architecture points to Transit Gateway, while quick setup over the Internet signals VPN. These connectivity tools define how traffic flows into, out of, and across AWS environments. Storage is another matrix to master. S3 is object storage scalable, durable, and versatile, but not a file system. EBS is block storage that attaches to EC2 instances, similar to a traditional hard drive. EFS is elastic file storage, accessible by multiple instances concurrently, making it ideal for shared file systems. FSX offers managed file systems tuned to specific protocols like Windows or Lustre. The key question is, what do you need the storage for? If it's for backups, logs, or large unstructured data, S3 is your choice. If it's tied to a specific instance, EBS is right. For multiple instances needing shared access, EFS or FSX fit the bill. Think of it as matching data shape to storage style. Databases come next, and here AWS offers a spectrum. RDS and Aurora provide managed relational databases, where structure and consistency are critical. DynamoDB is the go-to for NoSQL, offering scale and speed for key-value workloads. Redshift handles analytics at scale, optimized for queries across massive datasets. These services address different needs: transactional integrity, flexible scaling, or analytical power. The exam often tests your ability to map workloads. Millions of key-value lookups per second means DynamoDB. Complex joins on structured data signals RDS or Aurora, while petabytes of historical queries point to Redshift. Knowing which database fits which story is a major key to mastering Domain 3. Caching deserves a moment because it is often overlooked. Elasticache provides in-memory data stores like Redis or Memcached, cutting latency by avoiding repeated database queries. CloudFront serves as a global content delivery network, caching static assets close to users worldwide. Both services reduce load on back-end systems and improve performance. On the exam, look for scenarios describing repeated reads or high latency for global users. These often point toward caching solutions. The mental shortcut is simple. When speed matters and data repeats, caching is your friend. Serverless orchestration is another powerful area. API Gateway manages APIs, allowing secure, scalable access to back-end functions. Event Bridge routes events between services, while step functions string together multiple Lambda or container tasks into workflows. This trio forms the backbone of event-driven design, where applications react to triggers rather than waiting for scheduled jobs. For learners, it helps to see serverless not just as Lambda but as an ecosystem of tools that connect services together. The exam often cues this with terms like event-driven, workflow automation, or API management. Observability is about keeping track of what's happening in your cloud. CloudWatch collects metrics and logs for performance monitoring. CloudTrail records API calls, providing an audit trail of who did what. Config tracks resource configurations over time, highlighting drift from compliance standards. Together, these tools form the visibility fabric, ensuring that operations are not a black box. They answer the critical questions: is the system healthy? Who changed it? And does it comply with policy? In exam scenarios mentioning compliance, auditing, or drift detection, Config and CloudTrail are the right answers, while CloudWatch signals performance and health monitoring. Data and analytics services give AWS users the ability to move beyond raw storage into insight. Glue serves as an ETL, extract, transform, load engine to prepare and move data. Athena queries data directly in S3 with SQL syntax. Kinesis handles real-time streams, ingesting and analyzing continuous flows of data. QuickSight provides dashboards and visualization. These services align along a pipeline: capture with Kinesis, catalog with Glue, query with Athena, visualize with QuickSight. Knowing this flow is essential both for practical architectures and for answering exam questions that describe analytics needs. AI and machine learning options break into two categories. SageMaker is the platform for building custom ML models, giving full control to data scientists. AI services like Recognition, Comprehend, Translate, and Transcribe are turnkey, offering pre-trained models through simple APIs. The choice comes down to whether you need bespoke models or ready-made intelligence. For the exam, the distinction is clear. If the question is about custom training, SageMaker is the answer. If it's about plugging in vision, language, or speech features quickly, the AI services are correct. Security ties through everything. Encryption protects data at rest and in transit. Least privilege limits access, and private paths through VPC endpoints reduce exposure. These patterns recur across domains, underscoring AWS's shared responsibility model. Exam questions often hinge on recognizing whether the security need is about encrypting data, controlling identity, or reducing internet exposure. Always remember that security is layered. IAM, encryption, network controls, and logging all reinforce one another. Cost hygiene is not glamorous but is vital. Right-sizing resources ensures you do not overpay for unused capacity. Lifecycle policies automate transitions to cheaper storage classes. Commitments through reserved instances or savings plans reduce steady-state costs. Tagging enables visibility and chargeback across teams. These practices together form the financial discipline of cloud computing. On the exam, questions with budget constraints usually point toward one or more of these cost optimization strategies. Governance rounds out the wrap-up. Multi-account strategies with AWS organizations create clear boundaries, while service control policies enforce guardrails. Centralized audits and monitoring ensure compliance. The emphasis is on structure, organizing workloads not just by technology, but also by policy and oversight. The exam often cues this with language around enterprise governance or multi-team environments. Recognizing when governance tools are required shows that you can think beyond just the technical and into the organizational dimension of cloud. Finally, exam strategy ties it all together. Success lies in mapping scenario keywords to the right service. When you see event-driven, think Lambda or step functions. When you see shared file storage, think EFS. When you see long-term archival, think Glacier. This pattern recognition is not about rote memory but about logic. Each service exists for a reason, and once you see the alignment between requirement and tool, the right answer becomes clear. This is the ultimate takeaway from Domain 3. Cloud mastery comes not from memorizing names, but from understanding fit and purpose. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Batch and ETL extract, transform, load workflows form another core pattern. In these scenarios, large datasets are uploaded into S3, then processed by Glue to clean and prepare them. Athena can query the processed data directly, while EMR can handle larger-scale transformations with Hadoop or Spark. These jobs are usually scheduled or triggered by events, and CloudWatch provides monitoring. The key theme is that AWS separates storage from processing, allowing both to scale independently. For the exam, if you see a requirement to, quote, transform raw logs into analytics-ready tables or schedule recurring data preparation, think of S3 with Glue and Athena. This pipeline demonstrates the modularity of AWS data services where each piece does one job well. Streaming data brings different challenges, and AWS has clear solutions here too. Kinesis acts as the entry point, ingesting real-time data streams such as sensor readings or application logs. Lambda can process events from Kinesis in near real-time, applying logic before writing results into S3 or Redshift for storage and further analysis. This pattern addresses use cases like fraud detection, IoT telemetry, or live analytics dashboards. The exam cues for this include continuous data ingestion, real-time alerts, or millions of events per second. Recognizing the distinction between batch ETL and real-time streaming helps clarify which services to choose, with Kinesis marking the streaming path every time. Data lakes illustrate another strategic approach. S3 serves as the foundation, providing virtually unlimited, cost-effective storage for structured and unstructured data. Glue can catalog this data, while lake formation applies governance and access controls. This makes the lake not just a storage repository, but also a governed environment where teams can explore, query, and share data safely. The exam will often frame this as an enterprise-wide need for centralized data with fine-grained permissions. The right answer is the data lake architecture, anchored in S3 and extended with glue and lake formation. This pattern emphasizes AWS's role as not just a compute provider, but as a foundation for modern data ecosystems. Hybrid architectures are increasingly common, and AWS provides tools to bridge cloud and on-premises. Transit Gateway connects multiple VPCs and on-premises environments, providing a hub-and-spoke design. VPN and Direct Connect extend connectivity securely and reliably. Private link and resolver endpoints ensure that services can be accessed privately without traversing the Internet. The exam may describe hybrid connectivity or private access to AWS services as requirements. These terms point to the hybrid toolkit. This reinforces the reality that many enterprises move to the cloud gradually, needing AWS to integrate smoothly rather than requiring a wholesale migration. Hybrid thinking is as much about pragmatism as technology. Disaster recovery is a discipline in its own right, and AWS aligns services to Recovery Time Objective (RTO) and Recovery Point Objective (RPO) targets. Backups with AWS Backup or S3 can meet basic needs, while replication across regions supports more stringent requirements. Multi-region architectures can provide near-instant failover for critical workloads. The exam often signals DR scenarios with words like minimal downtime, data loss tolerance, or multi-region failover. The correct service mix depends on the tolerance described. Understanding the trade-off between cost and resilience is key. Higher resilience requires more investment, but AWS provides the flexibility to match business needs precisely. Performance optimization is another recurring theme. Caching solutions like Elasticache and CloudFront reduce latency. Partitioning strategies improve database scalability. Asynchronous queues like SQS decouple components, preventing bottlenecks. Autoscaling adjusts resources dynamically to demand. The exam cues for this include handle spikes in traffic, or decouple tightly coupled components. The key idea is that performance is not about a single service, but about design, using caching, partitioning, and scaling techniques together to create smooth, efficient systems. These are the levers architects pull to fine-tune user experience. Reliability practices build on similar principles but focus on resilience. Retries with exponential backoff ensure that transient failures don't cause outages. Idempotent operations prevent errors from compounding when retries occur. Stateless design allows workloads to scale and recover seamlessly. Health checks, often tied to load balancers or auto-scaling groups, help detect and replace unhealthy resources automatically. For exam purposes, look for terms like, graceful failure, resilient, or recover quickly. These are signals to recall AWS's guidance on building fault-tolerant architectures. Reliability is less about avoiding failure entirely and more about designing so that failure is expected and absorbed gracefully. Operational excellence is another core pillar of AWS. Infrastructure as Code, or IAC, allows you to define environments reproducibly with CloudFormation, or CDK. Continuous integration and deployment pipelines automate application delivery, reducing human error. Runbooks and playbooks document procedures, while alarms in CloudWatch keep teams alert to anomalies. Game days, where failure scenarios are tested deliberately, build confidence in recovery processes. These practices turn operations from reactive firefighting into disciplined, proactive management. The exam reflects this by framing questions around automation, consistency, and continuous improvement, pointing toward IAC and CI/CD solutions. Sustainability, though newer, is an increasingly visible consideration. AWS encourages the use of managed services, which consolidate workloads more efficiently than running fleets of underutilized servers. Graviton processors deliver better performance per watt, while efficient storage tiers reduce waste. For learners, this pillar is about recognizing that environmental efficiency is not just about good citizenship, but also cost savings and operational efficiency. Exam cues may include reduce environmental impact or energy-efficient design, which connect directly to these sustainability practices. Cloud adoption is, in many ways, about using resources more wisely. Cost controls go beyond hygiene into active governance. AWS budgets set thresholds and alert you before overruns occur. Cost Explorer provides detailed analysis of where money is going. Savings plans and reserved instances help optimize costs for predictable usage, while a portfolio approach balances flexibility and savings. The exam may describe scenarios where budgets must be enforced or predictable workloads must be optimized. Pointing toward these tools, the key takeaway is that AWS equips organizations with visibility and levers for controlling spend, not just relying on good intentions. Security remains a through line. Best practices include enforcing multi-factor authentication, avoiding public S3 buckets, rotating secrets regularly, and logging everything. These practices show up in nearly every exam domain because security is never isolated. It's baked into every design decision. The exam often disguises security questions within other topics. A database question may really test whether you remember to encrypt data, or a storage question may test whether you remember to block public access. Keeping security top of mind ensures you don't fall for distractors that ignore basic principles. Pitfalls are also worth noting because they are common traps. Hard-coding keys into applications, leaving security groups overly broad, and designing with a single availability zone are all mistakes that exams use as distractors. They may sound plausible if you are rushing, but recognizing them as anti-patterns helps you eliminate wrong answers. AWS designs for resilience, security, and scalability, so any option that undermines those should raise red flags immediately. Keeping these pitfalls in mind improves both your real-world practice and your exam performance. Exam strategy closes the loop. The trick is to align requirements with AWS's pillars: operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability, and then map to the right service. Distractors will often sound correct, but lack alignment with the requirement. For example, offering DynamoDB for relational joins should be eliminated, while RDS or Aurora would fit. The readiness check is whether you can read a scenario and translate it into a logical architecture on the spot. Practice builds this skill, but the structure remains the same: requirement, pillar, service. This is the mindset that carries you through both the exam and real-world cloud design. That concludes today's episode of the AWS Certified Cloud Practitioner Prepcast. Be sure to tune in for the next episode and visit us online at baremetalcyber.com or cyberauthor.me for more resources, including news, mailing lists, YouTube videos, podcasts, and much more.